Want to have a professional adjustable power supply? Don't buy it. Today, we will spend 3 minutes to solder it ourselves. LM317 is a classic 3-terminal adjustable regulator. It maintains a constant reference voltage of 1.25 volts to provide an accurate reference for the entire power supply, although its own output current is only 1.5 amps. It acts as the control brain. It will drive the subsequent power and achieve a wide range of 0 to 30 volts. Next, install a high-power bridge rectifier with rated current bridge rectifier. Its task is to transform the low-voltage alternating current into pulsating direct current. The current margin of up to 25 amps, ensuring long-term reliability under heavy loads. It provides abundant raw materials for the subsequent stage. Now, connect the main filter capacitor, 4,700 microfarads, 50 volts electrolytic capacitor. This large capacity capacitor is responsible for smoothing the pulsating DC after rectification. Filter out low-frequency ripples, making the voltage waveform flat. Providing a clean and coarse DC for the voltage regulator, we solder the first 10K potentiometer. It connects between the adjustment terminal of LM317 and forms an output voltage setting network, rotating the potentiometer and changes the resistance value between the adjustment pin and ground. The output voltage of LM317 changes linearly, thus achieving 0 to 30 volt stepless adjustment. Next, install BD139 medium power transistor, which acts as a driver here. Receives the control signal from the LM317. BD139 will drive the high power transistor behind. To prepare for current expansion, now solder a 1 ohm, 0.1 microfarad, 400 volt ceramic capacitor. It is connected in parallel between the DC output and ground, which is used to filter out high-frequency noise, to improve the stability of the power supply at high frequencies and anti-interference ability. It forms a high and low frequency match with large electrolytic capacitors. This 220 ohm resistor is connected between the output and adjustment terminals. Between the output and adjustment terminals, for the chips to provide the necessary operating current. This 10K potentiometer is used for output current limit adjustment. By cooperating with the sampling resistor, it sets the protection threshold. When the load current is too large or short-circuited, the circuit will automatically reduce the output. To protect the power transistor from burning out, 2 high-power transistors, 2N3055, appear. They are the core of the power supply's output stage. Each can withstand 15 amps of current. They can easily carry 10 amps in parallel. LM317 is driven by BD139. These 2 transistors form a Darlington structure to achieve high precision voltage following and strong current output. Note that they must be installed on a large radiator. Next, install 2 current sampling resistors of 0.25 ohms. They are connected in series between each the emitter and output of each 2N3055. Between the emitter and output terminal to detect the actual output current. When the current exceeds the set value, the voltage drop on the resistor will be fed back to, which triggers protection, achieving reliable overload and short-circuit protection. Finally, we connect the transformer. This is a 120 volt 10 ampere ring transformer. It isolates the 220 volts AC and reduces it to dual 12 volt alternating current as the energy source of the whole machine. The output of the transformer is connected to the AC input of the bridge rectifier. All power devices are connected. All components are welded. After power on, adjust to potentiometers. One sets the required voltage, and the other sets the maximum output current. Now a 0 to 30 volt, a high precision voltage regulator from 0 to 10 amps. It can provide stable and clean DC power.